20 million rows crossed out of the JVM into a Python process. The built-in version answered the same question with 0 rows crossing. That is what the pickle-based UDF cost here. About 30 times the equivalent built-in expression per row measured on this machine. 700 nanoseconds against 23 nanoseconds. And that is before Spark stops pushing your filter into the scan. Today, user-defined functions, and what leaving the JVM costs. Here is the measurement, on the kind of rule you already have in your pipeline. Sort each request into fast, okay, slow, or unknown when the latency is missing. One core, one Python worker, the same logic on both sides. The built-in chain of when and otherwise costs 23 nanoseconds a row. Written as a plain Python UDF, it costs 700 nanoseconds a row. 2 independent runs agree to within 1.3%. Episode 2.7. And the course keeps running on numbers like that one, so subscribe. Now, where do those 700 nanoseconds go? Before the timing, the part that costs more. Catalyst rewrites what it can read, and it cannot read inside your Python function, so it treats it as a box it must not move. Watch a filter. Written as a comparison on the column, the predicate goes down into the file scan itself, and the plan says pushed filters, status greater than or equal to 500. Wrap the identical condition in a UDF, and that list comes back empty, with a Python evaluation step above the scan. Your filter is no longer a filter. It happens after the read. So I counted them from inside the Python function itself, with an accumulator. On the 20 million row table, asking for server errors, the built-in filter matched 1,400,000 rows and put 0 rows through Python, because that plan has no Python in it. The UDF returned exactly the same rows, and every one of the 20 million had to be evaluated in Python first, because your function runs before Spark knows which rows match. Same answer. That is not a timing. A bigger cluster can spread the work out. For this plan, it does not make those evaluations go away. So what is actually crossing? On this version, a plain UDF is the pickle-based path. Your values are serialized out of the JVM, handed to a separate Python process, and the answers come back. Now switch that same scalar function to arrow serialization. One flag, no rewrite. The measured slope falls from 700 nanoseconds a row to 380 nanoseconds. That is the difference between two complete execution paths, not a price tag on Pickle by itself. Same function, same rows, a different serialization path, and it is still called once per row. Here is the one that bites in production, not in a benchmark. Your table has holes. Over 600,000 of these latency values are null, because those requests timed out. The built-in expression takes it in stride, null in, unknown out, the same 3-valued logic I unpacked in episode 2.4. The obvious Python version does not. It compares none with an integer and the task dies. Type error, less than not supported between none type and int. Not a wrong answer, a failed job. Even the examples in the PySpark documentation guard for none. There is also a bill that has nothing to do with rows. Your Python code runs in worker processes, and Spark can reuse those workers across tasks. I timed 1,000 rows, which is no work at all. On a single task, about 1 second. The same rows spread over 20 tasks on 20 cores, 11.5 seconds, rising almost linearly in this fresh local run. That number is my laptop, not a law of Spark. I have measured it nowhere else. But the shape of it is why the small sample you tested on could hide this cost completely. So here is the whole board, per row, on one core. The built-in expression, 23 nanoseconds. The pandas UDF, which receives a batch as a series and works on it vectorized, in arrow batches capped at 10,000 rows here, 190 nanoseconds, about 8 times. The same scalar UDF with arrow serialization, still calling your function once per row, about 16 times. The plain pickle-based UDF, about 30 times. And notice what none of the three fix. A Python evaluation node is still in the plan, so the filter still will not push down. So the rule. Before you write a UDF, look. This session lists 533 functions, and what you want is usually one of them, or a chain of when and otherwise like the one I measured. If your logic can be vectorized, reach for a vectorized API on purpose. And if you still need a plain scalar Python UDF, know which serialization it is using. On the version I measured, the default is pickle-based, and from 4.2 it is arrow, still row by row. Keep it out of filters and joins. We're not pushing down costs the most. Next episode, joins, and the one Spark quietly picks for you until your table gets too big for it.